students, relax, sit back and listen to our math class. In today's class, we are going to solve this problem. This problem is based on the sum of n terms concept. So kindly watch our previous videos on sum of n terms concept before watching this video. The link is given in the description. The question is, if the sum of m terms of an AP is the same as the sum of its n terms, show that the sum of its m plus n terms is 0. This question has been appeared in CBSE board exam 2017, right? So here, sum of m terms equal to sum of n terms. The given clue is sum of m terms equal to sum of n terms. We have to prove that sum of m plus n terms equal to 0. Right. So, sum of m terms means m by 2 into 2a plus m minus 1 into d equal to sum of n terms means n by 2, 2a plus n minus 1 into d. So, with this help of these two, we can conclude, we can derive some value, and with the help of that value and by this summation formula, we can finally prove that these values are equal to 0. So, cancel out these 2 and 2 and multiply this m inside. M into m minus 1 d equal to 2an plus n into n minus 1 into d. Now, we can move this part to left hand side. 2am plus m into m minus 1 into d minus 2an minus n into n minus 1 into d equal to 0. Next, we can do grouping 2a m minus n, these two values. Next, these two values. So, plus d into m minus 1 minus n into n minus 1 equal to 0. Next step, we can do 2a m minus m plus d multiplication. M square minus m minus n square plus n equal to 0. Right. Next step, 2a into m minus n plus d, m square minus n square minus m plus n equal to 0. 2a m minus n plus d. Here we can apply the algebraic identity. Here m square minus n square means m plus n into m minus n. So, m plus n into m minus n. Here minus, take minus as common one. So, what you will get, m minus n equal to 0. From this whole equation, you can take m minus n as common one. So, m minus n into 2a plus d into m plus n minus 1 equal to 0. Now, next step what we can do? We can move this m minus n to this side. So, what you will get, plus n minus 1 equal to 0, and this m minus n not equal to 0. This m minus n not equal to 0, but when it moves to this side, it will disappear. So, finally, you will get 2a plus d into m plus n minus 1 equal to 0. Assume this value as equation number 1, and now summation of m plus n. We already know that summation of n is n by 2 into 2a plus n minus 1 d. Here summation of m plus n. So, instead of this n, you will substitute m plus n in this formula. So, n means here m plus n by 2 into 2a. So, 2a plus n means m plus n minus 1 into d. We know that 2a plus d into m plus n minus 1 equal to 0. So, you can substitute by equation 1, this value becomes 0. So, into 0 equal to 0. So, summation of m plus n equal to 0, hence the proof. Here, what we did means, first step is sum of m terms same as sum of n terms. So, by using this formula, we have equated the sum of m terms and sum of n terms, and by doing various kind of work, we have derived this value 2a plus d into m plus n minus 1 equal to 0. By further simplification of that summation of sum of m equal to sum of n, we have derived this, and finally what we have to prove means sum of its m plus n terms is 0. So sum of its m plus n equal to this one. So you can equate these two values because 2a plus d into m plus n minus 1. Here 2a plus d into m plus n minus 1. This value equal to 0 means then by this equation this value becomes 0. So m plus n by 2 into 0 will give you 0. Hence we have proved that sum of its m plus n terms is 0. Thank you for watching. Subscribe to our channel for more videos related to both school and college maths. Thank you.